Hello, everybody. This is a piece of heaven from Encrypted Sigma. And as I always say, it's always better that you have a study buddy whenever you study Six Sigma. And that is my role in your life. You already know that. I'm studying Black Belt Six Sigma. I'm also a registered virtual instructor. So let me be in your life. Add and subscribe here. If not, okay, it's okay. Now, there's a lot of things that we will actually learn on this video, and the title of this video is to interpret the key results for display descriptive statistics. So if you haven't watched my previous video about descriptive statistics, go ahead and check it out. For the objectives of our video for today, in this topic, we will describe first the size of your sample, describe the center of your data, describe the spread of your data, assess the shape and spread of your data distribution, which is, I love this. I'm going to show a lot of graphs for you guys later on, and compare the data from different groups. So let's go ahead and start. Always, guys, remember you can go ahead and check the website for support.minitab.com because it's also the same thing. I'm using Minitab 19 as we speak. So step number one, describe the size of your sample. So always remember, even when you were in elementary, grade school, high school, college, you use the word or the letter N for number, right? The letter N to know how many observations are in your sample. Minitab does not include missing values in this count. Remember, okay, before you even start, check your data. Now, you should collect a medium to large sample of data, but it depends on the number again. You can use sample sizing for this, and we will discuss that in the next video. But samples that have at least 20 observations are often adequate to represent the distribution of your data. However, to better represent the distribution with a histogram, some practitioners recommend that you have at least 50 observations. Larger samples also provide more precise estimates to the process parameters such as the mean and standard deviation. So this particular picture, it shows to you the statistics of a particular study about the variable is about the torque, and as you can see, letter N is again represented by the number of your data, which is 68, and asterisk again tells you if there is a data that is missing values or it might be different, so there's nothing, that's why it displays as 0. And remember, if there's like an error or there's an N asterisk, that tells you that there's something wrong on that data or there's something that you should check. Okay? Always notice that. So that's the most important thing that we need. Okay, to be precise, guys, that's the only thing, right? Step number 2, describe the center of your data. Okay, you already know how many. Now we check the center of the data because that's somehow you need to measure, remember the bell curve, the sigma, stuff like that. So that's kind of advanced, but let's go ahead and check this one out. Use the mean to describe the sample with a single value that represents the center of the data. Now, many statistical analyses use the mean as a standard measure to the center of the distribution of the data. Now, the median is another measure of the center of the distribution for the data. The median is also usually less influenced by outliers than the mean. Half the data values are greater than the mean value, and half the data values are less than the mean value. You guys already know the definition of median and mean at the same time. So basically, it just shows you the picture in many tabs. So what you're seeing right now is not numbers anymore, but it's already interpreted as a beautiful painting. Beautiful painting. Now, the median and mean both measure a central tendency, but the unusual values called outliers and asterisk can affect the median less than they affect the mean. The median, okay? If your data are symmetric, the mean and median are similar. There we go. Why? later on about really need to fix the data when that happens. For the symmetric distribution, the mean blue line, which is here, and the mean orange line are so similar that you can't easily see both lines together. But the non-symmetric distribution is skewed to the right. Non-symmetric is skewed to the right. That's lower values. So you can go ahead and check the statistics there again. For the key results for mean and median, guys, in this result, the mean torque is required to remove a toothpaste cap, which is 21.265, and the median torque is 20. Like mentioned in here, it's almost um, near to each other. The data appear to be skewed to the right, which explains why the mean is greater than the median. I think it's like super clear right now, but it's very, very helpful, right? So, number three, describe the spread of your data. Use the standard deviation to determine how spread out the data are from the mean. A higher standard deviation value indicates greater spread in the data. So, in the results, the standard deviation is 6.42202. With normal data, most of the observations are spread within 3 standard deviations from each side of the mean. So, 1, 2, 3, 1, 2, 3. Okay, number four, assess the shape and spread of your data distribution. This is one of the most exciting parts when it comes to creating a descriptive statistics for you, because it assesses the shape and the spread of your data distribution. So use the histogram, the individual plot, and the box plot to assess the shape and spread of the data to identify any potential outliers. This is where you determine that, oh my gosh, like my 10,000, like your 10,000 cells or 20,000 cells in your Minute app already tells you in one picture super powerful information what happened to your data or what's happening to the process. It's amazing. Now, examine the spread of your data to determine whether your data appear to be skewed. But remember, when data are skewed, the majority of the data are located on the high or low side of the graph. High or low side of the graph. Often, skewness is easiest to detect with a histogram or box plot because uh, these individual bars would have their specific numbers, but here it doesn't have a number again. This one on the left side, it says right skewed and left skewed. Again, there will be a higher or lower side of the graph. So just determine that. So the histogram with right skewed data shows wait times. Most of the wait times are relatively short and only a few wait times are long. So there is an element of time in here, guys. The histogram with left skewed data shows failure time data. A few items fail immediately and many more items fail later. Determine how much your data varies. So data would varies, like it depends on what type of study you're doing. But looking at this, assess the spread of the points to determine how much your sample varies. The greater the variation in the sample, the more the points will be spread out from the center of the data. So, of course, again, this is interpreted in one picture. It's amazing. The individual value plot shows the data on the right that has more variation on the data on the left. Now, let's go ahead and look for the multimodal data. So this will all tell you that there are multiple peaks, also called modes. So multimodal data often indicate that important variables that are not yet accounted for. So if you have additional information that allows you to classify observation into two groups, for example, you can create a group variable with this information, and then you create a graph with groups to determine whether the group variable accounts for the peaks in the data. So this sample gives you the simple and with groups. Isn't it amazing? The last one, guys, is identify the outliers. It will just tell you the N asterisk. So if you like this video, click like and subscribe later on about really need to fix the data when that happens. For the symmetric distribution, the mean blue line, which is here, and the mean